not actually give you the polynomial expression. You are only going to get these pictures of algebra tiles, and so now we don't get to just skip step 1 like we were doing before. We actually need to write out what is the polynomial expression for each of these things. So if I have an x squared block here and an x squared block here, I have two x squared blocks. And if I have a negative x block in 3 different places, I'm going to say that I have negative 3 x blocks. And then if I have a 1 block and a 1 block, I'm going to say that I have 2 1 blocks. So this is my first polynomial expression. My second one, there's an x squared block. I only have 1, so I'm just going to say x squared. I have 2 x blocks, so plus 2x. And I have 3 negative 1 blocks, so minus 3. All right, because this is an addition question and we just have those secret ones that we're distributing, I'm not going to rewrite this whole thing. I'm just going to erase the brackets. So we would say we have x squared minus 3x plus 2, and we are adding x squared plus 2x minus 3. This should be 2x squared there. There we go. Yes, that all looks good. So I'm going to now, that was step number 1, was just actually writing out these polynomials. Then I'm going to group. So I will say, let's take my x squared terms and put them together. Then let's take my x terms and put them together. And then let's take my constant terms and write them together. Now I'll combine. And I get 3x squared minus x minus 1. Let's do another example. In this one, we have 3 of those x squared blocks. I have 5 x blocks, and I have 2 negative 1 blocks. And then we are adding, I have 1 negative x squared block, and then I have 3 negative x blocks, and I have 9 1 blocks. So I wrote my brackets all wonky so that I can just erase stuff because we don't actually have to worry about distributing right now. So let's not do it. That is writing out the polynomial expression. Now let's group like terms. 3x squared and x squared both have an x squared. And then 5x and negative 3x both have an x. Negative 2 and positive 9 are both constants. Let's combine these two. 3 minus, well, technically that's a 1. 3 minus 1 is 2, and it's x squareds that we're talking about. 5 minus 3 is also 2, and it's just x's we're talking about this time. And then negative 2 plus 9 is 7. We're talking about constants, so that is my answer right there. Let's go through one more of these together where I'm not putting them in order for you, nice and easy the way that I was up until this point. So I have negative 3x plus 5 minus 2x squared. And then I'm saying, let's add 6, and that's an x squared. And there are 6 negative x's there. Okay, same thing. 1 doesn't need to distribute, so let's not do it. That was writing out polynomial expressions. Now let's group terms that are like. So I'm not just looking at the start anymore. I actually need to be like, okay, there's an x squared, there's an x squared. There's an x, there's an x, there's a constant, there's a constant. So if I do these first two that have the x squareds, negative 2 plus, technically that's a 1. Negative 2 plus 1 would be negative 1. And so I actually don't need to put a 1 right there because of the same reason why this was a 1 right here. If there's no number, you just assume it's a 1. Negative 3 minus 6 would be negative 9. And the thing that we're actually counting here is x's. 5 plus 6 is 11. But hopefully we're starting to see some patterns. So when we have something like this now, this is the kind of question where I would say, find the perimeter. And a lot of people get freaked out because this isn't actually going to have a number on it. It's going to be like the perimeter is something multiplied by x, and you're going to have, it'll be like a polynomial with a variable as your answer. So what I do is I say find the perimeter in terms of x. And what that tells you is your final answer is allowed to have x in it. And in fact, if it doesn't have x, it probably means you've done something wrong. So the first thing we're going to do is we are going to see this little tick mark here and that tick mark there, these two here and these two here. That tells you that those sides are the same. Then what we're going to do is we are going to write out, okay, if I want the total perimeter, it's this side plus this side plus this side plus this side. Let me color code it a bit. I'm going to say that this side is this part of my polynomial. And then I'm going to say that this side is this part. This side is this part. This side is this part. So if I add all four of those things together, it should give me the perimeter to go all the way around this rectangle. That is where you need to get to be able to do everything, like this question right here now. This is something that we've kind of been building up to throughout this lesson. Getting to this part right here, this is where you would need to be like, okay, what do I know about perimeter? And then you would have to be like, okay, can I actually add this and this? And that's where we lay it out the way that I've got written right here. So now we can go through and do a question like this. We wrote it out symbolically. Now let's get like terms together. So I'm going to go, first of all, let's clear up these brackets. Like terms. So I see an x squared, an x squared. I see x, 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 x. Constant, constant. So I'm going to go, those are my x squared terms. Those are my x terms. and those are my constant terms. 2 plus 2 is 4. We're counting x squareds there. Negative 3 minus 3 is negative 6. Plus 1 is negative 5. Plus 1 more is negative 4. And then 4 plus 4 is 8. And so that's where we should get to with that one. So that's kind of how I can take a question that you think you've pretty much mastered after we've done like 6 or 7 of these examples here. And I can make you have to go back and kind of be like, do a little bit of problem solving. Be like, how well do I really understand this? Can I apply this stuff to a question where I need to figure out perimeter?